Hey third graders, welcome to Module 4, Lesson 9. Today we're going to analyze different rectangles and reason about their area, so how much space they take up. Let's get started. I want to nip this in the bud right now. There are some of you that are like, oh, Miss Pfeiffer, this area lesson is so easy. I'm so smart and so good, and why don't we do more complicated stuff? And I'm like, wow, that's so great. You're so excited about math. But wait, dun, 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 dun. Here's your mathematical future. I want you guys to know that there is a reason that we go through area step by step, like how we have been, because eventually you guys are going to have to find the area of area models that are called composite rectangles, which means that they're different smaller rectangles put together to make an interesting looking shape. And you're starting to train your brain to see the different parts and rectangles and squares that make up these shapes and figures, and using only the clues that you're given to find the area inside. So there is a reason that we go so slowly through this. So today's lesson, I'm hoping will feel pretty simple to you, but there is a reason that we do it. So please still take your time and really think about it. Okay, so in today's lesson, we're going to be starting with some big rectangles and cutting them into smaller rectangles. So our first one, I have a rectangle that is 20 centimeters long by 5 centimeters tall. If I want to cut my rectangle in half using a vertical line to cut it, where should I cut my rectangle? Go ahead and think about it. Okay, you should have remembered that I said that this was 20 centimeters long, so I'm going to cut it where the 10 centimeters is, because 10 plus 10 is 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I have two smaller rectangles. Now, did I change the area of my bigger rectangle? No, I just simply cut it in half. So it's like if I had a candy bar and I cut it in half, I still have the same amount of candy bar, it's just in two smaller pieces. So now I have two rectangles. I am going to call this rectangle A, and then I'm going to call this rectangle B. On your notes, I'd like you guys to write the area of rectangle A and the area of rectangle B. Go ahead and do that right now. Press pause and press play when you're done. If we're looking at our area for rectangle A and rectangle B, you should have thought that this is 5 centimeters by 10 centimeters. And both rectangles are exactly the same. So you should have thought that 10 times 5 equals 50 centimeters squared, or squared centimeters. And B is exactly the same. How'd you guys do? All right, if I was going to take my two smaller rectangles and combine them again to make one large rectangle, what is the area of the two rectangles put back together to make one big rectangle? Yes, you should have been thinking to yourself that it would be 50 plus 50 equals 100 centimeters squared, because we're taking the area of this, adding it to the area of this, and then we have 100 centimeters squared, or 100 square centimeters. How else could you write this equation? And the equation that I want you to think about is, how else could I write my equation for adding these two rectangles together? Go ahead and see if you can think of something besides 50 plus 50, since I already did that. Write it and press pause and press play when you're done. Okay, a different type of equation that you could have written would be something like 50 times 2, because I have two rectangles that each have an area of 50, so it's repeated addition. I could have also done parentheses to show my two rectangles being added together, but before I figured out the area. I could have also done and thought about how there are two 10 times 5s, which would equal 100 centimeters squared. There's just a lot of options, which is pretty awesome. Now, you guys haven't learned that putting the 2 just next to the parentheses means to multiply. So we could put the times there to show that we would multiply 2 times 10 times 5. Did the area change when I cut the rectangle? Nope, but I was able to think about making 2 smaller rectangles with my big rectangle. Let's try another one. Okay, now I have a rectangle that is 12 centimeters long by 4 centimeters tall. Think about where I can cut this so that I cut it in half. Where should I cut it? Here, here, here. No, yes, no, yep. I should cut it right in the middle here after 6 because 6 plus 6 is 12. So 1, 2, 3, 4, 5, 6. All right, so now I have rectangle A and rectangle B. Will you please find the area of rectangle A and rectangle B, and then press pause and press play when you're done. The first thing that I did, which I hope you did, was write down my side lengths for my 2 rectangles. Since they're twins, they're each 4 high and 6 across on our side lengths. Then you should have thought that each of them was 4 times 6, which equals 24 centimeters squared. Okay, let's say that I wanted to put the 2 rectangles back together again to make one big mega rectangle. What is the area of my rectangle when the 2 smaller rectangles are put together? Go ahead, figure that out, press pause and press play when you're done. All right, you guys should have thought that you already figured out the area for A and you figured out the area for B. So all you needed to do was simply say 24 plus 24 equals 48 square centimeters. How did you guys do? Now, if I was finding the area of these rectangles and I was playing with pulling them apart and putting them back together again to show that the area doesn't change even if we cut it apart and put it into sections. If I put them back together, I don't want to put them crooked or overlapping each other because then I have some of the area of B on top of the area of A, and that doesn't work because the area should be side by side to measure it accurately. Time for your final problem. You have 2 rectangles to look at, rectangle A, rectangle B. Your job is to find the area of rectangle A and the area of rectangle B. And then I want you to show me what is the combined area of rectangle A plus rectangle B if we were to put them back together again. Just in case you can't see it, rectangle A is 3 centimeters. It keeps moving around on me, by 1, 2, 3, 4, 5, 6, 7 centimeters. And rectangle B is 1, 2, 3, 4 centimeters by 1, 2, 3 centimeters. Okay, please solve that and I will see you guys tomorrow. Miss Piper, that was so easy. Good.